A quarter of a billion years ago, an epic story was starting to unfold all over the world. The heroes of this saga were the survivors of a near apocalypse. They emerged from it as humble creatures, but in time they came to dominate the earth. These were the reptiles, which grew to become some of the largest forms of life ever to stomp, swim, or soar across the planet. There were, however, some other noteworthy players in this story. The animals and plants that diversified in the shadows of the reptiles, many of which would go on to play key roles in our planet's future. Over millions of years, this whole troop of characters adapted to a rapidly changing world. But even though they grew to immense sizes and dominated all environments, many of the reptiles couldn't adapt to the changes that would bring their reign to an end. This age of reptiles was a spectacular prehistoric epic, and it all took place in a single era, the Mesozoic. The Mesozoic era began 252 million years ago, in the aftermath of the most destructive mass extinction of all time, the Great Dying. It brought to a close the previous era, the Paleozoic, and wiped out most marine and land species, leaving a world ripe for the taking, at least for anything that survived. In the early Mesozoic, Earth's land masses had almost finished merging into a single supercontinent called Pangaea, and that meant life could traverse the globe free of ocean barriers. The stage was set for the first act of the Mesozoic, the Triassic period. At first, the planet was populated only by the survivors of the Paleozoic. On land, there were the amphibian-like temnospondyls, and the early relatives of mammals called therapsids. Meanwhile, the seas were home to many groups of ancient fish, but also lots of reptiles that were adapted to life in the water. These first marine reptiles were mostly amphibious, but they quickly developed fully aquatic traits, including the ichthyosaurs, which came to resemble fish and later marine mammals, even though they were neither. And in the background, a special group of reptiles was beginning to take advantage of this newly open world. These were the archosaurs, a clade of reptiles that had its origins in the Paleozoic, but truly came into its own during the Triassic. Archosaurs include many of the animals you think of when you think of ancient life, like dinosaurs, pterosaurs, and the croc-like phytosaurs. And these creatures became key players in the Mesozoic because they were very well adapted to its environments. The skulls of archosaurs were lighter than their reptile ancestors, and most of them also had teeth that were set in deep protective sockets. Plus, they pioneered a unique unidirectional respiratory system, which was a network of air sacs that let them breathe more efficiently in a low oxygen atmosphere after the Great Dying. With the help of adaptations like these, archosaurs spread and diversified. And by the middle of the Triassic, around 243 million years ago, the real rising stars of the archosaurs appeared, the first dinosaurs. This is when the earliest known proto-dinosaur appears in the fossil record, Nyasasaurus, in what's now Tanzania. Soon after, we find evidence of the tiny omnivore Eoraptor and the predator Herrerasaurus, both in South America. And all of the earliest known dinosaurs were members of the same group, known today as Saurischians. You might call them Saurischians, but I'm sticking with Saurischians. They had the same basic things in common, like long necks and long tails and a generally reptilian body plan. But the thing I want to point out here is their pubis. That's one of the three bones that makes up the pelvis, including in you. You have a pubis. And in the case of Saurischian dinosaurs, the pubis bone always pointed down and forward. I know it's going to be hard for you, but try to remember that word, pubis, because I'm going to come back to it. Now, as dinosaurs started playing larger roles in their ecosystems, they also became larger and more specialized. And around 230 million years ago, they diverged into two of their most iconic groups, the long-necked sauropods and the two-legged, mostly meat-eating theropods. But while dinosaurs were becoming more diverse and widespread, another lineage of archosaurs was adapting to another environment, the sky. By the late Triassic, pterosaurs became the first vertebrates in the history of the world to take flight, with Eunomorphodon and others like it appearing in the fossil record throughout Europe some 210 million years ago. Meanwhile, other non-archosaurian reptiles were dominating the seas. Ichthyosaurs had been swimming the world's oceans since around the start of the Triassic. And by 200 million years ago, another group of semi-aquatic reptiles had given rise to the plesiosaurs, which adopted a totally different body plan for life in the water. This three-pronged takeover of land, sea, and sky allowed the reptiles to rule Pangaea. But it was not until the very end of this period that the last remnants of Paleozoic life would truly be swept away. 201 million years ago, Pangaea began to break apart as North America drifted away from the rest of the continent. This caused a spike in volcanic activity that sent greenhouse gases into the atmosphere. The resulting rise in global temperatures kicked off an event known as the End Triassic mass extinction. The casualties included most of the therapsids, temnospondyls, and other holdovers from the Paleozoic. And this left many niches open for the dinosaurs, pterosaurs, and other reptiles that would come to define the Mesozoic. Which brings us to the second act of this story, the Jurassic period, when the age of reptiles reached its peak. Hence the name of the park. By this time, dinosaurs had already acquired a variety of body plans and adaptations, and one of the most important was the spread of the ornithischians. Now, remember that pelvic bone I was talking about, the pubis? You remember, very good. Well, that's where a major change occurred in ornithischian dinosaurs. Instead of pointing down and forward, in ornithischians, the pubis was reversed. It pointed backward. This allowed ornithischians to have a larger gut cavity that could hold expanded digestive organs, and this helped them eat some of the toughest plants of the Mesozoic. Because of this adaptation, and with the help of new chisel-like teeth, ornithischians became the eating machines of the Mesozoic. Ornithischians probably first appeared back in the Triassic, but this was when they started to spread and diversify. The group became so successful that it eventually would grow to encompass many of the most prolific kinds of dinosaurs. All the hadrosaurs, ceratopsians, armored dinosaurs, and pachycephalosaurs, to name just a few. So in the early Jurassic, reptiles took center stage, moving into most of the large animal niches. But one group of fuzzy therapsids managed to survive into the Jurassic, and for a long time its members played only minor roles. These were the very first true mammals, like Megazostrodon, a tiny nocturnal insectivore that scurried around the feet of the dinosaurs. While there's some debate over whether mammals actually appeared at the end of the Triassic, they certainly diversified in the Jurassic. By the middle of the period, 164 million years ago, mammals had diversified beyond little shrew-like things to include species that could swim like beavers and glide like flying squirrels. And alongside these new types of mammals was a group of theropods that would also take to the air, acquiring the first complex wing feathers. By 150 million years ago, the first paravian dinosaurs, or stem birds, were starting to take off, although these animals, like Anchiornis, probably weren't very good flyers. As for the non-avian dinosaurs, the late Jurassic was when their most famous forms appeared. Legendary characters like the spiky Stegosaurus and the carnivorous Allosaurus patrolled the plains of North America. Meanwhile, giant sauropods like Giraffatitan roamed Africa. For these reptiles, the late Jurassic was a golden age, where they were the most obvious forms of life all over the planet. But as the period came to a close, Jurassic Earth was changing. The breakup of Pangaea was still underway. Sea levels began to rise, creating shallow seas in North America and Europe. And as these land masses moved, more events unfolded that led to a complex series of extinctions about 145 million years ago. Rather than being a single clear incident, these losses were the result of a constantly cycling climate of cooling and warming, and a jolt of volcanic activity, again, in the Pacific Ocean. These events ushered in the third act of the Mesozoic, the Cretaceous period. I know that traditionally the third act is supposed to be the shortest part of any drama, but in this case, the Cretaceous is actually the longest period of the Mesozoic. And the Cretaceous saw some of the most extreme changes ever recorded in both flora and fauna. One of its first breakthroughs was the appearance of flowers, which appear in the fossil record about 130 million years ago. Before these earliest bloomers, conifers, ferns, and cycads were the dominant plants. But now they had competitors, although it would be a while before flowering plants could become major players in the landscape. Meanwhile, dinosaurs were going through their own revolution. Again, feathered theropods called Coelurosaurs rarely got larger than dogs during the Jurassic, but they reached new heights in the Cretaceous. By 125 million years ago, big predatory Coelurosaurs like Utahraptor were roaming North America, while Utahraptor was hunting in China. And in the Middle Cretaceous, a new group of sauropods, the Titanosaurs, were outgrowing all of their Jurassic relatives. Some, like Argentinosaurus, are thought to have grown over 30 meters long and weighed nearly 70 metric tons. In the skies, pterosaurs also got way bigger, and by the late Cretaceous, they became the largest animals ever to fly. These were the giant Ashdarchids, which were as tall as giraffes, had wingspans the size of small airplanes, and were more than capable of feeding on small dinosaurs. Beneath the wings of these animals, the Cretaceous continents continued to drift apart, and dinosaur groups became more and more isolated, and also more distinct. For instance, titanosaurs became much more common in the southern landmasses, while in the north, a group of feathered coelurosaurs was reaching the rank of apex predator. These were the Tyrannosaurids, the largest of the tyrannosaurs. They first appear in the fossil record in the Middle Jurassic, but by the late Cretaceous, they had developed awesome crunching jaws and swift legs to help them deal with a whole new cast of ornithischians on their northern continents. Some of their prey, like ceratopsians, grew wild headgear, while ankylosaurids acquired armor to attract mates and fend off predators. But the duck-billed hadrosaurs were the most prolific herbivores in the north, thanks to their powerful beaky mouths and complex teeth that allowed them to eat just about any kind of plant. By the late Cretaceous, many of these dinosaurs were the largest and most bizarre that these groups had ever produced, showing just how successful the reptiles had become. Yet, they were about to see their age come to an end. For reasons that experts aren't quite sure about, some dinosaur groups, like hadrosaurs and ceratopsians, were becoming less diverse toward the end of the Cretaceous. This low species density means that some dinosaur groups were already vulnerable to extinction. And as it happened, doom was on the horizon. Rocks dated to 66 million years ago from a region of India called the Deccan Traps show signs of massive volcanic eruptions. These were some of the largest eruptions in Earth's history, lasting for tens of thousands of years, and the volcanic gases likely had powerful effects on the air and oceans. And in the midst of these eruptions, another disaster came. A giant asteroid struck the Gulf of Mexico, spewing ash into the atmosphere and creating an impact winter that starved plants and phytoplankton. These twin disasters threatened all life on Earth, but the largest animals, the ones that needed the most food, were most affected. The giant titanosaurs and ceratopsians and other herbivores wouldn't have been able to find enough food to sustain their bulk. And their decline meant that the large carnivores, like the tyrannosaurs, were doomed as well. In the seas, there were similar losses, including the extinction of the plesiosaurs and the mosasaurs. Other marine reptiles, like the ichthyosaurs and plesiosaurs, were already long gone by this time. Nearly 200 million years after they pulled themselves from the ashes of the Great Dying, all of the giant reptiles were wiped out. It's now known as the KPG extinction after the German abbreviation for Cretaceous and Paleogene, the two periods whose boundary is marked by this event. And it brought about the disappearance of 75% of the world's species. But thanks in part to their small size and their more varied diets, many Mesozoic animals survived into modern times. The three modern mammal groups, the placentals, marsupials, and monotremes, all made it. The flowers that first bloomed in the Cretaceous are now more numerous than ever. And even some of the mighty archosaurs have persisted into our day as crocodilians and as birds, the last surviving Saurischian theropod dinosaurs. But for the giant reptiles of the Mesozoic, their dominance turned out to be their downfall. When disaster struck, the niches that demanded large size and specialization were the first to go. It turned out that playing smaller parts in the story of our planet was a key to survival. And so as the next era dawned, the Cenozoic, it would be those once minor characters that would inherit the Earth. Thanks for sticking around for this very long story about the Mesozoic. I appreciate it. But please tell me what you want to learn about, because you have a lot of good ideas and we listen to them. So leave me a comment and don't forget to go to youtube.com/eons and subscribe. By the way, have you checked out Physics Girl? She's been nominated for a Webby, and if you check out her channel, you'll understand why. Your brain will thank you.